Hello guys, welcome to our next video in the playlist Google Earth Engine for land cover applications. So in today's video, we're gonna look at the next step of our classification model. So we had our first two parts. First is we have built a classification model with the help of random forest machine learning algorithm. So we have applied the classification model to two different areas, and we have assessed the accuracy assessment of the classification with the help of various measurements, like we have gone for the assessment of the kappa coefficient, the overall accuracy, the consumer's accuracy, producer's accuracy, as well as the F1 score. We have calculated, and we got to know that our model is working good and well. So next step in this part is that we are gonna go for the assessment of the area. So let's just start from where we have left. So you can go to my previous video on tutorial 35, accuracy assessment of our classification model, where we had calculated the error matrix, kappa coefficient, and the F1 score. So if you can just go to the description, you will find the code link in here. Just click on that so that we'll get back to where we have stopped in our last session. So this is our code. So if you can just see, we had our three region of interest. We had four classes in our classification model. First one is the vegetation, next is build up, and next one is the barren land, and last one is the water. So we had our satellite image for the year 2025. We had made a composite of it. We have added so much layers to our map, and we trained our model with the help of four classes, and we have used the two classes of training for GCPs for training as well as testing. So we have used this testing class, that is the 30% for validation of our model, and the 70% for training our model. So after that, we have trained the features with our image collections. We have used the random forest machine learning algorithm with the 500 number of decision trees in order to get the better classifier, and we had our first classified image, and later we had just the accuracy assessment with the help of our uh, testing GCPs, and we calculated the matrix, the error matrix, and we got the accuracy, overall accuracy, consumer's accuracy, producer accuracy, kappa coefficient, and the F1 score. So till here we had in our last session. So now we want to calculate the area of these classes. So that is the main prime target of this video. So whatever you do the classification, always the final objective is to get what is the total area under this class. Let's say we have the vegetation, so what is the total vegetation cover of this area, so how much it is covered by the built up structures, how much we have the barren land in order to carry out the developmental projects or uh, some kind of recreational projects, or how much we have the water land, water bodies. So everything is the main motto here. So now let's just start by adding a comment called, we are going for the area assessment. So you just have a comment called area calculations. So I will show you both of the methods where you can calculate the area of vector data also, and you can go for the calculating the area of the raster data type also. So if you can just go to our documentary and search area. So first we'll start with the feature. So feature is nothing but a vector data type. So we have one function called area. So you just open this. So here you will find the description of this function. So it says that this will return the area of a feature's default geometry, and where you can have to give the arguments such as the target feature which you want to calculate the area of it, and the maximum error. It means what is the error margin that this function can accommodate. So maximum you can give up to zero point 0.1. So don't ever give the max error to be the maximum value. So have it the low values as much as possible. So you need to also specify the projection, in which projection you want to calculate the area of your shapefile. So let's just start. So I will calculate the area of our region of interest one, ROI1. So you see here we had three region of interest. So for the first ROI which is showing in my map, I will calculate the area and I will show you the differences. So let's just come back to our area calculations, and you create a variable called area of a feature. So must be area feature. So I have my ROI 1. This is my feature for which I have to calculate the area, and I simply use the area function. That's it, my area is calculated. So now just print the area feature and rename it as area of ROI 1 and give it a run. So we have kind of error here because it's a feature collection, so it's not working. So we need to make it a geometry, or you can just go to ROI1 and import it as a feature. That's it, you change here. Now you click on the run. Now it should work. So the styling is not working, so it's not a problem. You can always remove this. So what we'll do is that we'll create a one more ROI1. So let it be a feature collection because we're getting maximum errors here. So I'm gonna replicate this, or you just say we're gonna create a one more ROI, or simply you can go for any administrative boundary. So I have created a geometry here, so you just have to draw a shape. Yeah, select this box, and I will create one region of interest. So let it be this one, and I'll rename it as let it be geometry only. So you just scroll back down and find your area here and rename it with the geometry. So let's just run it. So I should get the region of interest now. So this has to be a feature because we are calculating it for feature, so it doesn't has to be a geometry. So now you have changed the feature type to be a feature, not a geometry. So let's just click on the run. So we're getting some errors. So through this you can also learn how we can manage the errors. So we need a non-zero error margin. So you just click on the specify and make it a dictionary. So I need a maximum error to be zero point 0.1 square meters and projection to be APSG 32639. 32639 32643. So that's the EPSG code for India. So we got an unexpected token. I didn't close the flower brackets. So now you click on the run. Yeah, now it has loaded. So here you see my region of interest area ROI1. So whatever the geometry I have drawn here, so the area of this is this much 6579 0 point something. So this is in the square meters. So what if I want to calculate in terms of square kilometers? So you just have to divide this by 1 to the power of 6, so that you will get your area in terms of square kilometers. So I hope guys you have understood how you can calculate a simple area for this vector. So it's just a bounding mode. So instead of this, you can have any kind of administrative boundary. So if you can have a shapefile of entire Karnataka or a Mysore district or a Bangalore district, you can still go for this. So remember, but it test has to be a feature, so you don't apply this to a feature collection. So try to understand the difference between a feature, a geometry, and a feature collection. So this function is for applying for a feature. So now let's just go to our next step, that is calculating the area of our classification. So I'll delete this geometry, and let's just to go to calculating the area of our classification image. So we have the comments here, so area calculations. So let's just start. So now my first task is to get what is the area of my vegetation cover. So let's just start by class 1. So let's take create a variable called vegetation. So I have my classified image dot classified roi1. So out of this, I have to get the vegetation from this class image. So I have to make it a binary image. Remember, my vegetation is class number 1, so I am using one operator called here equals dot 1, so that I'll get all the classes which are equal to 1. So if you can just add it to layer and see what does it contain. So just do map dot add layer vegetation. So you can leave the visualization for default and rename it as vegetation, close it, run it. So what you should get is a binary image. So whatever we will get all the values which have the pixel value of 1 will be our vegetation. So as of now, you just uncheck all of this, so you can have a classified ROI1. So if you can just compare, so wherever there are white colors, so those are all vegetation. So it's a binary image classified into two classes of 0 and 1. So wherever you find 0, those are all non-vegetated. Wherever you find 1, those are all vegetated areas. So we have achieved it with the use of a function called equal. So remember, this only works on the image. So if you have an image collection, you have to filter it down. You have to use ee.filter.equal to, because that will be an image collection. Now I have a single image, filters does not work. So I have to use dot equal function, so that I will get whatever the pixels equals to the value of 1. So if you can change this value to 2, you will get all the areas with the build up. So I hope you have understood how you can extract the vegetation pixel from my classified image. So now let's just calculate the area. So I'm creating a variable called area. So if you can just search area in here and scroll it down, here you will find one function called ee.image.pixel area, which will generate an image in which the value of each pixel is the area of pixels in square kilometers. So the image will return the function will return an image with a single band called area. So you need no arguments, so just create this image dot pixel area. So now I have an image with the pixel calculated around it. So now I have to create one more variable called area in area, let's say in square meters, because whatever the area you get will be in the square meters by default. If you want to convert it down, you have to multiply them with 1 to the raised 1 raised to the power 6, so that you will get the areas in square kilometer. So now whatever my classified now classified whatever my area is there, so I'm gonna multiply them, not multiply. So whatever my area is there, I will just add the bands of my vegetation, and I will use a function called reduce regions. Reduce region, and click on the space for autofill, so you will get some of the arguments. So what is the reducer you want to use? I want to use e.reducer.sum because I want to get what is the total vegetation around this area, and I want to have the geometry, which is my region of interest 1. And what is the scale? Scale is 10 meters. Remember, the scale is always the scale of your Sentinel-2. So you have to give some additional parameters because the area is somewhat large. So you have to give the best effort to true, so that it will use all the computational capacity, and it will have avoided the error. So you have to give the max pixels, let's say 1 E13, and tile scale to be 16. So please remember to give all three of the additional parameters like best effort, max pixels, and tile scale only if your data is too large. So if your area of interest is very much smaller, so you don't have to use it. So now my area in square meters is ready, and I will print it down. So let's just print area square meters in terms of area vegetation. So let's just run it. So scroll it down. Here you will find your dictionary is loading. So it's a dictionary object. Computing, you have the area of your vegetation. It has the sum, whatever the results will be in terms of square meter. So it will take some time because the area is too large. So it have to compute the areas. So let it load. So yeah, it's loaded now. So if you can just expand the object, you will get your area. So here you have to multiply because it's a single image. So yeah, our dictionary is loading. Yeah, it has loaded. So now it has only got a single property. Expand it, you have the area 94 square meters, something 94,830. So it's somewhat less interpretable because it is in terms of square meters. So how can I convert this to square kilometers? So let me just for this area map, I will just divide them by 1e6, so 1 raised to the power 6. So you can rename it as area in square kilometers, and this is the area in square kilometers for my vegetation. So this is how you can convert from square meters to square kilometers. Divide the pixelated area by 1 raised to the power 6, so that you will get your results in the square kilometers instead of square meters. Yeah, now you will see my square kilometers. My vegetation area is 94.8 square kilometer is the total vegetation cover of my area. So this is how you can calculate a single class uh, area calculation. So I will just mark it down here. So area calculation of a single class. So now we will go to next part where we will calculate the area for all the four classes at once. So here you will find one more comment, area calculation for all the classes at once. So now I'm creating one more variable called pixel area. So again, you don't need to calculate the pixel area, so you already have this area, which is ee.image.pixel area. So I will directly create the last layer, that is all class area. So for my area, I will divide it by 1 e6 so that all my results will be in square kilometer, much interpretable. I will add the band of my classified ROI1, and I need to use the same function called reduce regions, not reduce regions, so just reduce region. So remember the difference, reduce region and reduce regions. So I need to specify reducer, so I need sum of it, so I'll use ee dot reducer dot sum, and I need to use one more parameter called here dot group, because I want to group the areas according to its class. So use the function dot group. It will ask you for two arguments. What is the group field you want to use? This is my first group field. And what is the name of that group should be? It should be based on the classification. So just fill the rest of the geometries. ROI 1, your scale is 10 meters, your CRS is not required, transformation is also not required, best effort must be true, yes, use all the best efforts that you can, and your max pixels is 1e13. So remember, if you only have the larger region of interest, then only specify these three parameters of best effort, maximum pixels, and tile scale to be 16. So you can close the brackets. We should also close here. Yeah, so that's it. My all class area is done, so I'm gonna print it. Print this all class area. So we'll again get a dictionary, so to rename it as area of all classes in square kilometers. Run it. Scroll down. So here you have, so we have seen how you can calculate the area of single class, how you can calculate the area of all the classes at once. So remember, you got groups, you have four groups based on your four classes. So see, for the classification one, that was our vegetation, we have got the same result, 94.83, 94.83 square kilometer. For the second class, that is our builder, we have 89 square kilometers. For the third class, which is our barren land, so much of the area is covered by the barren land, so yeah, it is 123.73 square kilometers. And the last one, water body, as you can see in the map, there is low water body, so we have only 5 square kilometers of water body in our region of interest first. So I hope guys you have understood how to calculate the area. So we have seen three major steps here. So one is how you can calculate the area of a feature, that is your vector data, and how you can calculate the area of your raster data. So first we have seen how you can extract a single class from your classified image and then calculate the area in terms of square meters. Then you can calculate in terms of square kilometer by dividing your pixel area image with 1 raised to the power 6. And then we have also seen how you can calculate the area of all the four classes at once using a special function called group. So with this I will end the video here. So I hope guys you have understood how to do this. If you have any kind of queries, doubts, so you can always post in the comment section. So thank you for watching.